Hello viewers, in today's class we are going to study one of the important methods of integration which is known as integration by substitution. Viewers, I will be explaining this method of substitution by deriving these formulas, the formula number 3, 4, 5 and 6. Clear? So we'll study the method of integration by substitution by deriving these formulae for the integral of tan x, for the integral of cot x, then the integral of sec x, and then the integral of cosec x. Clear? So let us start. So here's our first integral is integral of tan x. Now we have to find the integral. Now here we are going to use the substitution method. So when we solve this integral, we'll understand how to apply the method of substitution. Clear? And moreover, viewers, these 6 formulas are very elementary formulas in integrals, and we will make use of these formula in our later discussions. Clear? So these formulas will be applied directly, so we must remember these formula. Clear? Now here the first one is integral of sin x, which is minus cos x, and integral of cos x is sin x. So these two formulas or the integrals are here we have written them directly from the definition of integration. Clear? Okay, now let us derive the integral of tan x. Okay, so tan x can be written as sin x divided by cos x. Clear? Now here we have cos x in the denominator. So let cos x is equal to t. Clear? So here we will substitute cos x is equal to t, and will transform this integral from the variable x to the variable t. Clear? Now differentiate both sides. So we have minus of sin x is equal to dt over dx. Now this can be written as minus dt is equal to sin x dx. Clear? Now here in place of this sin x dx, we can substitute minus dt. So here we have minus dt divided by t. Clear? Now the integral of we know that the integral of 1 over x dx is log of x. So therefore this integral becomes minus log of t plus c. Clear? C is the constant of integration. So here we can write minus log, and in place of t we write cos x. Clear? So this is the formula for the integral of tan x. Now this can also be expressed like this. How? We can write log of cos x. Cos x can be written as 1 over sec x, and if we take sec x to the numerator, we have sec x, and we have a negative of here, or we can write directly as plus log sec x. Clear? Here we have used the property of logarithms, that is log of m raised to minus 1 is minus of log m. Clear? So the integral of tan x is minus log cos x plus c or log of sec x plus c. Clear? Now let us come to the integral of cot x. Now we have the integral of cot x. This is integral number 4. So we have cot x dx. So this can be written as cos x over sin x dx. Clear? Now viewers, here we'll put t is equal to sin x. So this substitution has been made and we are changing this variable x to the variable t. Clear? Now we differentiate it. So we have here cos x. So dt is equal to cos x dx. Clear? Now for cos x dx, here we can write dt over t. Clear? Because sin x is t. Now this is log of t plus c. And what is t? T is log of sin x plus c. So here's the integral of cot x is log of sin x plus c. Clear? Now let us take the integral of sec x. Now here we can write or we can express this sec x by multiplying the numerator and denominator by sec x plus tan x. Clear? Sec x plus tan x. So here we have to remember this step, because if we write sec x as 1 over cos x, then we do not have or we can say that there is nothing to simplify. So what we will do, we'll multiply sec x. Instead of writing sec x as 1 over cos x, we multiply sec x and divide sec x by sec x plus tan x. Clear? Okay. Now multiply sec x with this sec x, so we have sec square x plus sec x tan x. Clear? And in the denominator we have sec x plus tan x. Clear? Now let us substitute t is equal to sec x plus tan x. Clear? Now differentiate both sides. So we have the derivative of sec x as sec x tan x, and the derivative of tan x is sec square x. So dt over dx can also be written as, or we can write dt as sec x tan x plus sec square x times dx. Clear? So here in place of this we can have dt. Clear? And in the denominator we have t. Clear? So this can be written as log of t plus c. Now viewers, this can be expressed as log t. Again we substitute the value of t here, so log of sec x plus tan x plus c. So the integral of sec x is log of sec x plus tan x. Clear? Now let us take the integral of cosec x. Okay, so here's the integral of cosec x dx can be written as this is cosec x multiplied. Now here again we have to remember one thing. We multiply and divide cosec x by cosec x plus cot x. Clear? Cosec x plus cot x. Now this step can be written as, if you multiply both these terms, so here we have cosec square x plus, here we have cosec x cot x divided by cosec x plus cot x dx. Clear? Now let us substitute t is equal to cosec x plus cot x. Now differentiating both sides, we have the derivative of cosec x as minus of cosec x cot x, and the derivative of cot x is minus of cosec square x. Clear? Now this expression can be written as we take negative sign common, and then we take negative 2 in front of dt here. So we have cosec x cot x plus cosec square x dx. Clear? Now this value cosec square x plus cosec x cot x dx can be replaced by minus of dt, and in the denominator we have dt. So here's this is minus of log of t plus c, and we can write minus log, and the value of t is cosec x plus cot x plus c. Clear? So this is how with the help of integration by substitution we have derived these 4 formulas. Clear? So here's we must remember all these 6 results, because these results will be utilized directly in our later discussions. Clear? Now let us come to some more important results related to integration. Now viewers, here I am going to tell you one important result in integration which can be directly applied to some problems. Clear? So here's if we have an integral like this, that is, if we have a function or an integral, or we can say the integrand is in the form of f prime of x divided by f of x, then the integral of such a function can directly be written as log of f of x plus c. Clear? Now what does it mean? It means that suppose we have this say we have to write the integral of cot x. Now cot x can be written as cos x divided by sin x. Clear? Now we see that this sin x is fx, this fx is sin x, and its derivative is in the numerator. This is cos x. So the direct integral of this function is log of sin x. Clear? Because log of fx, so here fx is sin x, so we have this function. Clear? So the integral of cot x dx is log of sin x plus c. Clear? Similarly, if we have a function say it like this, if it is 10x, and if we have secant square x in the numerator, then we see that the derivative of 10x is secant square x. So the direct integral is log of 10x. Clear? Plus c. Similarly, if we have say suppose we have to find this integral, then we can write this integral as 1 over 1 plus x square dx divided by tan inverse of x. So yes, we see that the derivative of tan inverse x is 1 over 1 plus x square. So therefore this integral is equal to log of tan inverse x plus c. Clear? So we'll always remember this result. Clear? Now viewers, we know that the integral of e raised to x is e raised to x plus c, because the integral of the indefinite integral of the exponential function is the exponential function itself. Clear? Now here now we would like to find what is the integral of e raised to ax dx. Clear? What is the integral of this function? Here we have e raised to x, so the direct integral is e raised to x. Now if we have e raised to ax, where a is some real numbers, some real number, so here we'll make use of integration by substitution. Okay, so what we will do, we'll put t is equal to ax. Clear? We'll substitute t equal to ax, and then we differentiate both sides, so we'll get dt is equal to a times of dx. Clear? Now dx can be written as dt divided by a. Clear? Now this integral is equal to e raised to t, so this is e raised to t multiplied in place of dx we can write dt over a. Clear? So this a is a constant, so we can write it outside the integral sign, so we have 1 over a integral of e raised to t dt. Now the integral of e raised to x dx is e raised to x, so we can have e raised to t and plus c, and again we'll replace this t by e raised to x, so 1 upon a e raised to ax plus c. Clear? So here's from here we realize that if we have an integral e raised to ax dx, then we write e raised to ax and then we divide by this constant here. Clear? So for example, if we take e raised to 2x dx, then what is its integral? Its integral is e raised to 2x divided by 2 plus c. Similarly, the integral of e raised to minus 2x is e raised to minus 2x divided by minus 2 plus c. Clear? Similarly, the integral of e raised to square root of 2x dx is e raised to square root of 2x divided by square root of 2 plus c. Clear? So we must remember that integral of e raised to x dx is e raised to ax divided by a. Clear? Now viewers, let us take one more topic here. If we have the integral of say sin x is minus of cos x plus c. Clear? We know that the integral of sin x is minus of cos x. Clear? Now what about the integral of sine of ax dx? Clear? So again we'll make use of the integration by substitution method. So we'll put t is equal to ax, so dt is equal to a dx and dx is equal to dt divided by a. Clear? Now this integral is expressed as Sine ax is sine of t and dx is dt over a. Clear? We take a outside this integral sign and we have sine t dt. Now this can be written as 1 upon a, and this is minus of cos of t plus c, because the integral of sine t is minus of cos t, and again resubstitute this value here and we have minus 1 upon a cos of ax plus c. Clear? So here the integral of sine ax dx is equal to minus 1 upon a cos ax. For example, if we want to find sine, say 5x dx, so this is 1 upon 5 minus cos of 5x this is minus 1 over 5 cos 5x plus c. Clear? Similarly, if we want to find sine of say 10x, then it is minus 1 over 10 cos of 10x plus c. Clear? Okay. So yes, this is how we find the integral of sine ax dx. Now let us see this is minus 1 over a cos of ax plus c. Okay, now if we want to find the integral of cos ax dx, then we know that the integral of cos x is sin x, so we divide the result by this scalar a. So this is 1 over a sine of ax plus c. Clear? So we should always remember whenever we have a number a or a real number a with x, the coefficient of x is a, then we should divide it the result by a. Clear? Okay. Now here we can also say that if we have the integral of say ax plus b dx. Now what is the integral of this function sine ax plus b? So let us find it again by making use of integration by substitution. So we'll substitute t equal to ax plus b, then dt over dx is a, because the derivative of x is 1, and here the derivative of b is 0, because a and b both are some constants here or real numbers. So we have a here. So dt over a is equal to dx. Clear? Now this integral becomes sine of t, because ax plus b is t, and dx can be written as dt over a. So here this is 1 over a, and the integral of sine t is minus of cos of t plus c. Clear? So this can be written as minus a cos of ax plus b plus c. Okay. So as an example, we can say that the integral of say, if we want to find the integral of say sine 2x plus 3 dx, then what we will do, we'll divide the result by 2. So the integral of sine 2x plus 3 is minus of cos of 2x plus 3, and we divide it by 2. So this is minus half cos 2x plus 3. Similarly, if we want to find the integral of e raised to 2x plus 3 dx, then again the integral of e raised to 2x plus 3 is e raised to 2x plus 3, and we divide it by 2 by this constant. Clear? And this is plus c. So we should remember how to write the integral of the terms like sine of ax, cos of ax, tan of ax, or sec of ax, and similarly sine of ax plus b, cos of ax plus b, and so on. Clear? Now viewers, let us solve some problems um, which can be solved directly by using substitution method. Clear? Viewers, here I would like to tell you that whenever we solve problems related to integrals, we must first examine the function which is to be integrated. Clear? So we must closely examine the structure of the function which is to be integrated, because once we examine this function, then we can devise the strategy to integrate this function. Clear? So here because we are doing problems related to method of substitution, here it is quite evident that this question or this problem will be solved by substitution method. Clear? So let us solve this problem, and here we have to find this integral. So let us denote this integral by this letter I. Clear? Now let x plus 4 is equal to t. Clear? Now we are substituting x plus 4 is equal to t. So we get dx, if we differentiate both sides, then we get dt over dx is equal to 1, because the derivative of x is 1 and the derivative of 4 is 0. So therefore dt is equal to dx. Clear? Now if we substitute the value of t and the value of x plus 4 and dx, here we get the value of x is t minus 4 and square root of t. Clear? And for dx we have dt. Clear? So we have changed this integrand from the variable x to the variable t. Clear? Now we can write this function as t divided by square root of t, then minus 4 divided by square root of t and dt. Clear? Now this can be written as, because this is t raised to 1 and this is half, so we have t half here and minus 4 times of t raised to minus half. Clear? dt. Now here we will apply the formula for x raised to n dx. Clear? So we have x raised to n plus 1, here we have n plus 1, so here we have t raised to half plus 1, then we have half plus 1, minus 4 times t raised to minus half plus 1, this is minus half plus 1. So yes, this is t raised to 3 by 2, this is 3 by 2, so we can write 2 by 3, and minus this is minus half plus 1, this is half, so we have 8 here, 8 t raised to half plus c. Clear? Here also we can write plus c. Now substitute the value of t as x plus 4, so the result is 2 by 3 times x plus 4 raised to 3 by 2 minus 8 times x plus 4 raised to half plus c. So this is the required integral of this function. Clear? Here's, let us take this problem here. Let us denote this integral by I, and we have this function here, and as I have said earlier that we must closely examine this function. Clear? This is the, I think this is the basic rule while doing the problems of integration. We must examine, or we must take a close look at the function which is to be integrated, because here we can simplify this expression. See, if I take 2 common from this term, we have 2 times of 2x plus 1. Clear? So this expression can be written as 2 times of 2x plus 1, and this is the integral sign, and then we have x square plus x plus 1 dx. Now here, see, if I differentiate this quadratic function here, then we get the derivative as 2x plus 1, and which is present here. The derivative of x square plus x plus 1 is present here. See, so that's why I am saying that before solving the problem, such problems, we must closely examine the function which is to be integrated. Clear? Because we can derive a lot of conclusions from the given function. So here we can express this function like this. Now put x square plus x plus 1 is equal to t. Clear? So dt over dx is equal to 2x plus 1. The derivative of 1 is 0. So we can write dt as 2x plus 1 times of dx. Clear? Now this I can be written as integral, and we can group the terms like this. This is 2 times of x square plus x plus 1, and then we have 2x plus 1 times dx. Now this is equal to dt. Clear? This is equal to dt. This is dt. So I can be written as integral 2 times, this is square root of t, because x square plus x plus 1 is t. So 2 times of square root of t times dt. See, this is how we simplify this integral. Now we take 2 outside the integral sign, because constant can be taken out of the integral sign here. So we have 2 times t raised to half dt. Now we apply the formula for x raised to n. So we have t half plus 1, we have half plus 1 plus c. So yes, this is 2 times t raised to 3 by 2. This is also 3 by 2 plus c, and we have if we take 2 to the numerator, we have 4 by 3 times t raised to 3 by 2 plus c, and then we substitute the value of t as x square plus x plus 1 raised to 3 by 2 plus c. So this is the required integral of this function. Clear? Now viewers, let us take this problem and let us denote this integral by I. Now we have to find the integral of cos x divided by square root of 1 plus sin x. Viewers, once again I am telling you that we must closely examine the structure of the function which is to be integrated. So here we see that if we differentiate 1 plus sine x, so the derivative of 1 is 0 and the derivative of sine x is cos x, which is in the numerator. Clear? So let us substitute t is equal to 1 plus sine x. Clear? So we have dt over dx is equal to cos x. Clear? So dt can be written as cos x dx. Now for this term we can write dt, and in the denominator we have square root of t. Now this can be written as t raised to minus half dt, which can be written as minus half plus 1. The integral of t raised to minus half is t raised to minus half plus 1. This is minus half plus 1 plus constant of integration. So we have t raised to half, this is half plus c. Clear? So this is 2 times of square root of t plus c. Clear? So which can be written as 2 times of, we again substitute the value of t as 1 plus sine x. Clear? Plus c. So this is the required integral of this function. Clear? Now viewers, here I would like to tell you one more thing. Suppose instead of substituting t is equal to 1 plus sine x, if we substitute t square is equal to 1 plus sine x. Why? Because we have a square root of 1 plus sine x. So we have t is equal to 1 plus square root of 1 plus sine x. So instead of 1 plus sine x equal to t, if we take t square is equal to 1 plus sine x, then what will happen? Then we'll differentiate both sides. So we have 2t here, 2t dt over dx equal to cos x. Clear? The derivative 1 is 0, cos sine x is cos x. So we have 2t dt is equal to cos x dx. Clear? Now for cos x dx we write I is equal to, it becomes 2t dt, and in the numerator we have square root of 1 plus sine x, and square root of 1 plus sine x is t. Now this t and t get cancelled, so we are left with 2 dt, which can be written as 2 times integral of dt, and we have the integral of dt because we know that this is t. So this is 2t plus c. And what is t? T is square root of 1 plus sine x plus c, and c, these two are same. So we got the same answer or the result. Clear? So whenever we do problems on integration, we should examine we should closely examine the structure of the function to be integrated. Clear? Now viewers, let us take this problem. We have to integrate 1 plus cos x. Viewers, let us integrate 1 plus log x whole square divided by x. Clear? Now here also we will make use of integration by substitution. Now let t is equal to 1 plus log x. So dt over dx is 1 over x. The derivative of 1 is 0 and the derivative of log x is 1 over x. So dt is equal to dx over x. Clear? Here we have dx also. Clear? Now for dx over x we can write dt and for 1 plus log x we write t, so the integral becomes t square dt. Clear? For dx over x we have dt, and 1 plus log x is t, so this is t square. So yes, this is 2 plus 1 divided by 2 plus 1 plus c. This is t cube over 3 plus c, and again we substitute the value of t as 1 plus log x. So we have 1 plus log x cube divided by 3 plus c. Clear? So this is the required integral of this function. Clear? Okay. Now similarly, let us integrate one more function. Say I equal to e raised to tan inverse x divided by 1 plus x square dx. So here, as I have said earlier, we have to closely inspect the function which is to be integrated. So we see that the derivative of tan inverse x is 1 over 1 plus x square. So therefore we'll substitute t is equal to tan inverse x. So when we substitute t equal to tan inverse x, we have dt over dx equal to 1 over 1 plus x square. Clear? So therefore dt is equal to dx over 1 plus x square. Now for dx over 1 plus x square, we can write, we have here dt, then here we have e raised to t, because tan inverse x is t. So the integral of e raised to t is e raised to t plus c, and we have e raised to tan inverse of x plus c. So this is the required integral of e raised to tan inverse x divided by 1 plus x square. Clear? Now viewers, let us integrate this function 2 cos x minus 3 sin x divided by 6 cos x plus 4 sin x. So let this integral be I. Clear? Viewers, as I have just said, that we have to closely inspect the function, and if we examine this function, we realize that if I take 2 common from the denominator, then we have this function 2 cos x minus 3 sin x divided by, if we take 2 common, so we have 3 cos x and 2 sin x. Clear? Now we see that the derivative of 3 cos x plus 2 sin x is the numerator. See, if I take t is equal to 3 cos x plus 2 sin x, then the derivative of t with respect to x is minus 3 sin x plus 2 cos x, and dt can be written as 2 cos x, if we write it 2 cos x minus 3 sin x times dx. Clear? So see, here we have 2 cos x minus 3 sin x dx, and this whole quantity can be replaced by dt, and we have 2 times of t here. Clear? So we can take 2 outside this integral sign, we have 2 half integral of 1 over t. This can be written as half, and integral of 1 over t is log of t plus c, and it is half log, and again we substitute the value of t as 3 cos x plus 2 sin x plus c. Clear? Now viewers, let us take this problem. We have to integrate cos square root of x divided by square root of x. Now here again we'll make use of substitution, and let t is equal to a square root of x. Clear? So dt over dx is half root x. Clear? The derivative of square root of x is 1 over 2 times square root of x. So dt can be written as or we take 2 here to this side, so 2 dt is equal to dx over square root of x. So here's for this term dx over root x, we can write 2 dt, and for cos root x we can write cos of t. Clear? Now we take 2 outside this integral sign, and we have 2 cos t dt, integral of cos t dt, and we have 2 times the integral of cos is sine, so we have sine t plus c, and we can write 2 times sine of square root of x plus c. Clear? So this is the required integral of this function. Clear? Now viewers, let us integrate this function e raised to 2x minus e raised to minus 2x divided by e raised to 2x plus e raised to minus 2x. Let I is equal to this integral. Clear? Viewers, again we have to closely inspect this function, and we see that if I substitute t is equal to e raised to 2x plus e raised to minus 2x, then dt over dx is equal to 2 times of e raised to 2x, this is minus 2 times e raised to minus 2x, and we can write 2 e raised to 2x minus e raised to minus 2x, and then we can write dt over 2 is equal to e raised to 2x minus e raised to minus 2x dx. Clear? Now see, e raised to 2x minus e raised to minus 2x dx, this term can be replaced by dt by 2. Clear? dt by 2, and in the denominator we have t. Clear? So we have half integral of dt over t, which is equal to half, this is log of t plus c. Clear? So this can be written as half, this is log of t, and in place of t we write e raised to 2x plus e raised to minus 2x plus c. Clear? So this is the required integral of this function. Clear? Now viewers, let us have this problem. We have to integrate cos x minus sin x over cos x plus sin x. So let this integral be equal to I. Clear? Now viewers, here we see that, or we examine that the derivative of cos x plus sin x is the numerator. Clear? So if I take t is equal to say cos x plus sin x, then we have dt over dx is equal to minus sin x plus cos x, and dt can be written as cos x minus sin x dx. Clear? So for this term we have dt, and in the denominator we have t, so this is log of t plus c. Clear? So here's this is log of cos x plus sin x plus c. Clear? So the integral of this function is given by log of absolute value of cos x plus sin x plus c. Clear? Now viewers, let us solve this problem. We have to integrate sine cube x cos square x and say this integral is equal to I. Okay. Now viewers, again we will closely examine this function, and this function can be expressed like we can write it like this. We can write cos x dx here, and then we have or we can write say if we write it like this, cos square x, this is cos square x, then we write sine square x. We split sine cube x in like sine square x and sine x dx. Clear? So this is sine x dx. Now we can write cos square x times, and for sine square x we write 1 minus cos square x. Clear? And this is sine x dx. Clear? Now here we'll put t is equal to cos x. Clear? So dt is equal to minus sine x dx. Clear? And if we take minus dt here, we have minus dt is equal to sine x dx. Clear? Now here we substitute this value, and for cos x we will put t, and we have t square here, 1 minus t square, then we have minus of dt. Clear? Now this can be written as this is t square minus t raised to 4, this is minus dt, or we can write t raised to 4 minus t square dt. Clear? Now the integral of t raised to 4 is t raised to 4 plus 1, 4 plus 1, minus t, integral of t square is t raised to 2 plus 1, this is 2 plus 1 plus c, and we have t raised to 5 divided by 5, t raised to 5 divided by 5 minus t raised to 3 divided by 3 plus c. And again we substitute the value of t as cos x. So here we have cos raised to 5x, cos raised to 5 divided by 5 minus cos cube x divided by 3 plus c. So this is the required integral. Clear? Viewers, in this lecture we have seen, or we have solved a number of problems related to integration by substitution method, and in our next lecture we'll be discussing some more methods of integration, and till then, goodbye.